What's going on, Geo Metro Ninjas? Welcome to another exciting edition of Coach O's Corner. Today we have the privilege of talking about transformations. Okay, we're going to start with translations and reflections. Okay, but then we're going to go into rotations and dilations as we continue throughout this unit. Okay, so first things first, what is a transformation? A transformation is something that changes the size, how big or small it is, position, where it's located, or orientation. Maybe it flips it upside down, turns it on its side, along those lines. Okay? It is an operation that maps the original figure, which we call our pre-image, onto a new figure called the image. You'll note here, okay, when we draw our pre-image, so our pre-image is the letter A, okay? Look in that highlighted spot. There is no tick mark. But then you get your transformation arrow, bloop, 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 and you get A prime. Okay? That prime tells the person reading your work that something has happened. They have transformed from where they were. Our first transformation we're going to talk about is a translation. Okay, and all we're going to do is slide across the coordinate plane. We're not turning anything upside down. We're not flipping anything. We are just simply moving our pre-image across the coordinate plane. It's almost like if you've got a cup on your desk and you take your cup and you slide it to the other corner, you translated your cup. So it moves every point of our figure the same distance in the same direction. Much like our orange jumpsuited friend in Despicable Me, who was committing crime with both direction and magnitude. Oh yeah! A vector is moving it a distance and a direction. Okay? This is our notation. So this is the way you'll see a lot. X comma Y transforms with that arrow to X plus H, Y plus K. If you remember last year, you were taught about hippos and kangaroos. So hippos, they're big. They can only shift side to side. That's our H. That's our X change. Kangaroos can hop up and down. That's our vertical change. Okay? You can also see a translation written in vector notation. Oh yeah. Okay, and that's these little brackets here, H comma K. So it takes out the X, it takes out the Y, just tells you what the X comma K is. So we want to describe our transformation in words. Essentially, what is happening if I were to verbalize, okay, what's happening. So we look at the first example, X comma Y transforms into X plus 2, Y minus 10. So remember, our initial is X plus H, comma, Y plus K. So we are moving, if X is positive, it's going to the right. So we're going right 2. And then if Y is negative, it means we're going down, down 10. Same thing for number 2. Okay. X comma Y transforms into X minus 5, Y plus 7. If X is negative, that means we're going left. Okay. Left 5. And then if Y is positive, that means we're going up 7. They can also just give us our graph. The biggest thing is we identify the pre-image. Notice, if we look at the letter B, there's nothing up here. There's no prime notation. So that means this is our pre-image. Okay? This is our pre-image, no prime. Because if we move down on here, look at there's that prime. That means something has happened. It is not the first iteration of B. So we kind of treat this like slope almost. We're going to start at any of our vertices, A, B, C, or D. It does not matter because they're all going to travel the same direction, the same distance. Okay, so I'm going to go down here to my A, and I'm just going to connect so I can count a little easier. And so what we see is, I'm going to cheat so I don't have to count like that on the picture for you guys. No, I counted one earlier. Just bounce around for a little. There it is. I knew we had one from earlier. Okay, so we went down 10 units and right 11. So that's what we're talking about. So finding the distance, the difference is not that bad. Okay. Now what comes next is now we're going to start to use our rule we want. So I got those two up there done. That's fine. Okay, so it wants to translate left 12, so that would be a negative 12. And down 1, so negative 1. So x comma y translates x minus 12, y minus 1. Okay. Translate right 4 up 2. So that's a positive 4 and a positive 2. Remember, right is positive, up is positive. Left is negative, down is negative. So x comma y translates into x plus 4, y plus 2. Now you could write that in vector notation. Vector notation is a little quicker. Okay? And all it is you got this guy, then you write your h is 4, and your y is 2. Now let's actually graph a transformation. So when we look at our picture here, okay, they're giving us this rectangular looking figure, okay? X plus 8, y minus 12. So that means we're going to go right 12 or right 8 and then down 12. So we need to get the coordinates of our picture. And again, I'm going to cheat a little bit just so I don't have to do media magic. I'm going to go ahead and grab these guys so you guys can see. Maybe put the hold music in there. Probably not. We don't need to. And bam, studio magic. Okay, so that's the vertices of our figure. This piece right here is how you guys are going to show work on your initial transformation project. Okay, this is the work. All right, now what we're going to do is we're going to do the math. Negative 7 plus 8 is 1. 8 minus 12 is negative 4. Negative 1 plus 8 is 7. 8 minus 12 is negative 4. And then we do that as we continue down. Negative 7, positive 7, negative 9. Right. And now that's what we go ahead and plot onto our graph. 3, 2, 1. Just like that. And then when you write it in there, make sure you put your prime notation. Our next transformation we're going to learn is our friend, the reflection. When you look in the mirror, everything's the opposite of what it was, right? A reflection is similar. Look at our example up there. We got a smiley face, but when you reflect him, he looks like he's a frowny face. Okay? This is our flip transformation. Okay? Each point is equidistant from the line of reflection. For you guys, we're going to stay focused on 4 lines of reflection. Don't worry, you will get these given to you, but our project, you should be able to refer to your notes. Okay, so we can reflect the x-axis, which is x negate y. We can reflect the y-axis, which is negate x, y stays the same. We can reflect the line y equals x, which we're going to switch the original y and x locations. And then we can reflect the line y equals negative x, which is we're going to switch them, and we're going to negate both. So again, I'm going to use a little magic here to kind of copy this so when I make this new one, you don't hear me sitting there trying to struggle and count the. All right, so remember, this is how you show work on your presentation. This is your work. Draw an arrow, put the rule underneath what you did. So now, when we do this one, 1, x stays the same, so it's 1. -7 times -1 is +7. 4 times 1 is 4. -2 times -1 is +2. So we can almost see this as multiplication, guys, as we go through this process. Okay, 9 times 1 is 9. -2 times -1 is 2. And then 6 times 1 is 6. -7 times -1 is +7. Okay, and what you should see with a little bit of magic is this figure is going to flip over this one. So when we go back to the graph, we can see it. It looks like the x-axis is a mirror and our parallelogram is kind of going along it. Okay, let's grab this guy next to it. I'll do one more and then I'll let you free. So again, it's kind of like that partitioning a segment where it's not difficult, right? This isn't necessarily inherently a difficult topic. However, if you're not diligent in following through with how you would activate stuff, it can be tough. I can 100% understand. Okay, this time we are going to reflect the y-axis, which means we are going to negate our original x. And like I said, we can almost treat it as multiplication. Okay, -9 times -1 is 9. 6 times 1 is 6. -6 times -1 is 6. 9 times 1 is 9. -3 times -1 is 3. 6 times 1 is 6. -6 times 1, -1 is 6. And then 3 times 1 is 3. Then that is also a great way for us to look at it because when we start to get to dilations and we're multiplying by our scale factor, we're already comfortable with multiplying. So we look at our picture, it's going to flip over the y-axis. And would you look at that beauty? Let's do one more. I know I told y'all that was the last one, but I'd like to do one where it flips over one of those weird lines, right? Hey, I'd like to do one of those. Like this guy is so good looking here. Let's go ahead and get this guy out of there. So you can see before we go down and do the math together, you can see that this is the line we're going to reflect. We're going to reflect the parent function that is y equals x. That's our basic, goes through the origin, slope is up 1 over 1. Okay, that's the parent function of our linear equations. All right, let's do the math. Let's see what happens. Let's paste this on here. Okay. And magic. All right, so all we're going to do is we're going to take our x and our y, and we're just going to swap their location. So notice it was 2, -4. So now we get -4, 2. We're not changing any of the signs. We're not multiplying by -1. We're just swapping places. So 7, -4. Swip them around. -4, 7. 7, -9. -9, 7. And then -9, 2. And again, guys, you can go back and watch this video as many times as you need to. Rewind, hit pause, stand and deliver, whatever you need to do to understand it. Okay. So guys, this is our lesson on translations and reflections. If you want to get a head start on your project for this weekend, what I would recommend is get your pre-image knocked out, and then you can reflect it. So now you've got half the project done, and then Monday and Tuesday. Monday night you can do rotations, and then Tuesday night you can do translations and dilate. And Wednesday you can turn it in, and then you get the 6 bonus points, and you kind of get a couple study halls the rest of the week. Guys, I appreciate you. Know that I love you, care about you, and I want you to be great.